Now, in today's video, we will learn what is cloud computing, then we will understand what is AWS, then we will explore why it is so popular. After which we will explore the infrastructure and technology of AWS. Then we will configure out the benefit of AWS followed by some popular AWS services. And in the last, we will cover top companies using AWS these days. So, without doing further ado, let's get start the session. So, what is cloud computing? Cloud computing is the distribution of computing service via the internet. The cloud computing including server, storage, databases, networking, software, analytics and intelligence to provide faster innovation in a more flexible resources and economies of scale. You usually only pay for the cloud services you use, which help you cut costs, run your infrastructure more efficiently, and scale up as your business grows. Now that we know what cloud computing is, let's understand the very important and popular aspect for it, AWS. What is AWS? Amazon Web Services or AWS is a cloud computing platform that manages and maintains hardware and infrastructures, reducing the expense and complexity of purchasing and running resources on site for businesses and individuals. These resources are available for free and for a fee per users. It is a comprehensive and simple to use computing platform offered by Amazon. Infrastructure such as service platform as a service and package software as a service are all used to build the platform. Now, our next topic is why it is so popular. AWS offers a diverse range of cloud computing products and services. Server, storage, networking, remote computing, email, mobile development, and security are all services provided by Amazon. Amazon extremely successfully sector. AWS has considerably surpassed its competitor in terms of size and impression in the computing world. Did you know that in 2020 AWS broke the record of being a 10 billion business? So, come let's go through the infrastructure and technology of AWS. AWS operates globally in 25 regions across 6 continents. Each region consists of multiple availability zones. These are the physical data center where computers reside, which are geographically isolated to lessen the chances of a local tragedy affecting a whole region. Furthermore, AWS Continent Delivery Network has over 200 edge sites around the world, which is known as CDN. In addition to the publicly available reasons, there are few special reasons. The AWS government cloud services available in two regions for those working in for US government and in China. There are two regions that are run by local qualified firm in compliance with Chinese law and regulation. AWS owns high-speed fiber optic network, connects all of these region availability zones and edge sites. AWS has been developed in its own hardware to improve the speed and reliability of its network. You probably already familiar with the AWS network. AWS customer include Netflix, Twitch, Reddit, Slack and Hulu. Now that we know almost everything about AWS, its infrastructure and technology, Now let's have a look at the benefit of AWS. So following are the pros of using AWS services. AWS enables enterprises to use programming models, operating system, database and architectures that they are already familiar with. It is a low cost service that let you pay only for what you use with. No upfront fees or long time commitment. You will not have to pay for the operations and maintenance of data centers. It offers fast deployments and it is simple to increase or decrease capacity. Now, let's explore some of the popular AWS services. Here are some important cloud compute services offered by Amazon. EC2 or Elastic Cloud Computer. It is a cloud-based virtual machine on which you have complete control over the operating system. This cloud server can be used at any time. Lightsail. This cloud computing solution manages and deploys the computer storage and networking resources needed to execute your applications. Elastic Beanstalk. This program allows for automated resource deployment and provisioning, such as high scalable product website. EKS Elastic Container Services for Kubernetes. This solution allows you to run Kubernetes or Amazon's cloud without having to install it. And AWS Lambda. You can use this AWS service to run functions in the cloud. You can save a lot of money by using the tool because you only pay for when your function work. So as we have covered so much about AWS, let's move further and have a look at the top companies using AWS. Here Instagram, Zoopla, SmugMug, Pinterest, Netflix and also Dropbox. So all these companies uses AWS in their work. In this video, we will discuss about creating an AWS account for free. So, to create this particular account, you would need your credit card or debit card, which is mandatory, or as a prerequisite, you are supposed to have your debit card or credit card ready before you start creating your AWS account. So, how come it is free while you are using your debit card or credit card? AWS has an offer to make wherein if you use couple of instance which is claimed to be free for next 12 months, then they would not charge you for anything. In case if you cross that limit, then it would start putting the charges on your credit card or the debit card that you have used to create. So be careful when you start using AWS because you have already given your credit card or debit card. But if you follow all the instructions that I am going to give you in this session, then you can easily start using AWS for next 12 months without paying any charges. Okay, great. Let's begin. To start with, let's visit Amazon Web Service website aws.amazon.com. On the home page of your website, click on create an AWS account in here. You are supposed to pass your email ID as well as give a new account name. Now you have to verify your email. After verification, we have to create a new password, confirm it and then continue. Once you go to the next page, it would ask you whether it is professional account or free account. So choose it as personal account since it's going to be your personal account. Enter your phone number, your region, your address and finally here click on this to agree the customer act. So you can definitely click on this and then open the agreement and go through it. Nothing to worry, but it's always better to look at the agreement because they keep changing the agreement every now and then. So please go through it, and then once you have gone through it, select to agree and click on create account and continue. So in the third screen of your AWS sign up page, it would ask you for your credit card or your debit card detail. So let me enter mine: expiry date, holder name, and CVV number. So, and I would say use the current address itself as my billing address, and add in case if you want to show it for your tax saving. And then if you want to actually mention it, you can go ahead and then click on yes and enter your PAN number. If you don't have it, you can verify and add. So you would see that you would receive an OTP to the registered number of your credit card or debit card. Let me enter my OTP that I have received. Since it's an Indian card, so it's going to deduct only 2 rupees. In case if you have a card from outside, then it may deduct about $1 fees for your account. But whatever deduction that it does right, it would send it back to you. This is just to validate if your credit card or debit card is valid and then usable. Okay, so let me enter the OTP and click on next. So that means my card is now validated and it's asking for my cell phone number. So again, enter the cell phone number, enter the captcha that you've seen out here, and click on send SMS. Or otherwise, you can also request for a voice call, so that it will send you a voice call in which you will get an OTP for verification. So let me send an SMS. Now let me enter the OTP and simply click on verify code. So my account has been now validated and verified. In here, be careful when you choose this detail. Always click on the free plan, the basic plan that you have, include all the account, 24 by 7 services, etc. Do not click on any of other plans. If you click on it, then it will start deducting the amount that you see there. Okay, so let me click on free basic plan, and then in the screen it will ask you to submit your role and your interest. In here you can probably skip this or click on submit to move on. Okay, so since you are in this screen, your account is actually created and your account is already validated. All you have to do now is click on sign in to the console. Here enter your email ID and your password that you choose. There you go, you have successfully created an AWS free account. Now okay, so in here there are a lot of free videos which are available for you to start with AWS Amazon Web Services. Now here if you click on this all services, you can see all these services which are provided by AWS. Hello friends, welcome to this channel. In this session, we are going to discuss about S3 default encryption. So without any further ado, let's get started the session. So if you wanted to push an object into an S3 bucket and wanted to make sure that that object was encrypted, then you would force encryption using a bucket policy, and the bucket policy sees that if the encryption headers are not specified in the API call made it to Amazon S3, then you deny the request, right? And therefore the effect of that every object that is put it into your S3 buckets has to be encrypted. Now that's one way of doing it, but there is another way, and it is to use the default encryption option in Amazon S3. So the idea is that if you upload an unencrypted object into Amazon S3, it will be encrypted using the default encryption options. But if you already uploaded encrypted, then it will not be re-encrypted. Now, something should notice that bucket policies will be evaluated before default encryption. So, for example, if you wanted to force an encryption mechanism of SSE S3, for example, you would need to use the bucket policy. But if your requirement is just to make sure that every single object in your bucket is encrypted, for this you could use default encryption. So now let's see practically. So let's create a new bucket over here. Here in bucket name, let's say S3 default encryption demo 2022, and then simply we are going to create this bucket. So now under the bucket itself, as you can see for properties, you have a look at default encryption, and here we can automatically encrypt a new object stored in this bucket. So we will edit and enable it, and we will select it, the type of encryption scheme we want. Do you want do you want Amazon SSE S3, or do you want SSE KMS? And then you specify your key. So we will use SSE S3 for this example, and it will save my changes. And now, as you can expect, if I add a file over here, for example, let's say this castle.jpg or jpg, and then as you can see, I do not specify any encryption mechanism here. So simply upload and click on close here. Now if I go to my object and have a look at the encryption field in here, then we can see that yes, server side encryption setting is enabled for this object, and it was using the server side encryption Amazon SSE S3. Okay, now if we try to upload another object now, so now let's upload a mountain.jpg, but this time in term of properties I am going to specify encryption key, and here we can use either the default encryption bucket setting or we can override them. So if we override them and for example use this KMS using the managed key AWS S3 KMS key. So now simply click on upload, and now we have a look at the file itself. So let's click on it and scroll down to the encryption block. Here we go. As you can see, now even though default encryption is enabled, this file was encrypted using SSE KMS and the KMS key that we specified. So remember, the default encryption is not applying the same encryption to all files. It is just making sure that if you upload the object in unencrypted way, then you will automatically be encrypted using the default encryption mechanism. In this session, we are going to discuss about Amazon S3 access logs. So without any further ado, let's get started the session. S3 access log. So say that for audit purposes, you want to log all the accesses into your S3 buckets. So that means that any request that is done to Amazon S3 from any account, authorized or denied, you want it to be logged into another S3 bucket. So you can analyze it later. So you can analyze it, for example, using data analyzing tool or something we will see in the further session called Amazon Athena. So here's the idea with the diagram. We will request into a bucket, and that bucket has been enabled for login into another bucket or login bucket. And so all the requests, once we have enabled the S3 access logs, will log all the requests into the login bucket. So it's very easy, very simple, and the log format is defined here. So if you are interested about how we can read this log, just click on this link. And okay, so now something you should know about this login buckets, that is very pretty natural, but you need to know about it once. So do never ever set your login bucket to be the bucket you are monitoring. Otherwise, if you set the login bucket and the monitoring bucket to be exactly the same, then it will create a login loop and your bucket will grow in size exponentially. So let's see here. Let's say we have a bucket. It happens to be our application bucket and also the bucket that is going to receive all the logs. And so therefore, whenever a user puts an object, the bucket is going to log inside of itself, create a login loop, and they will create a new object. They will be logged in a new object that will be logged. So it creates an infinite logging loop. So that's that's why your bucket will grow in size exponentially. So my advice to you is, do not try this in your personal account. This will end up in huge AWS bill for doing this little mistake. So always separate your application bucket and your login bucket. So now let's go in the hands-on, so you will you will see how this will work. So as you can see, this is my AWS S3 console. Now let's demonstrate S3 access login. So let's create a new bucket. I will call it demo S3 access logs 2022, and then I will leave all this setting on and click on create bucket. Okay, so this is creating my bucket, and this bucket is going to be used for access login for my other bucket, right? So now let's take my demo S3 bucket 2022, and I'm going to turn on server access login. So for doing so, I am going to go into properties, and I will scroll down a little bit over here, and I will find the server access login in here. Next, I will click on edit, and then simply enable server access login. Next, I need to specify a target bucket. So I can just browse Amazon S3 and select the bucket that we just needed. Choose the path, and we can do, for example, slash logs slash. If you want to have all the server access logs to go under the S3 dash logs folder, it's up to you, it's optional, but add a trailing slash at the end. Now save the changes, and we are good to go. So now it is enabled, and the idea is that if I go and, for example, list my versions here, if I go and take this castle.jpg file and open it, and this is going to generate some traffic onto my bucket. Okay, and this is going to be logged onto my other bucket called demo s3 access log 2022. Now this can take an hour or 2 hours to appear, so I am going to wait a little bit for it to be written. But one question you may have is, by turning on the server access login, how is this bucket getting the right to my logging bucket? And so it says here, by enabling server access logging, the S3 console will automatically update your bucket access control list, that is ACL, to include access to the S3 log delivery group. So let's check this out. Let's go to permission of my demo S3 access log bucket. And under the permission, if I scroll down and go to access control list SEL, yes, the S3 log delivery group has the right to write my objects onto my S3 bucket. So this is something that has been added automatically by Amazon S3 when I did enable server access login. Okay, so now the only thing I have to do is wait. So I will pause the video and hopefully within an hour or two I should be able to see some objects being populated in here. So I'll see you very soon. Okay, so I am in my access log bucket. I have waited an hour. So hopefully now I started seeing an S3 log folder here. So that has been created. So perfect. And within that folder, it's contain access logs of what has been done on my S3 bucket. So I can take any of this file. I can take this one, for example, and I can download it. So as you can see, it is a text file. So I'm going to open it with my any text editor to see what it's inside. And so I just opened this file and this is the text file, as you can see. So this is one line. So this contains 1 bit of information in this specific file. And this tells me about the request ID, the bucket it was made on, the time and date of this bucket request, the IP it's coming from, and that is fact it was a get. So it was a successfully get on a bucket. So it was probably like a request done at the top of the bucket. So this type of access logs can be analyzed at scale using something like Athena that we will see in the further sessions. And so on their own they are not very helpful, but if there are any problem, if there is any authorization issue or attack whatever, Athena analyze these files and getting down to the bottom of it will allow you to get more insight into what is happening, right? In this session we are going to discuss about Amazon S3 replication. So without any delay, let's start the session. Amazon S3 replication, that is CRR and SRR for cross region replication and same region replication. At its core of the idea, we have an S3 bucket, for example, in one region, and we want to replicate it asynchronously into another region, into another bucket. So to do so, we first must enable versioning in the source and destination buckets, and then we can set up two different things: cross region replication CRR if the two buckets are in the different regions, or same region replication SRR if the two buckets are in the same regions. Note that the buckets can be in different accounts, so it is very possible for you to save a copy of your data into another account using S3 replication. The copying happens asynchronously, but it is very quick. And for the copying to happen, you need to create an IAM role. We will see in the hands-on, and that IAM role will have the permission from the first S3 bucket to copy through the second S3 buckets. So the use the use cases for cross region replication is for compliance or lower latency access of your data into another region. So, or to do cross account replication and SRR, so same region replication, the use cases could be log aggregation. So you have different login bucket and you wanna centralize them into one bucket, or leave replication, for example, between a production and your test account. And so here is the fine print about S3 replication. After you activate S3 replication, only the new object are replicated, so it is not retroactive. It will not copy your existing state of your S3 buckets. And for delete operation, there is an option setting to tell tell you whether or not you want to replicate your delete marker from the source to the target, or if you specify the deletion of a specific version ID, then it is not going to be replicated to avoid malicious deletes. And finally, there is no chaining of replication. That means that if bucket 1 has replication to bucket 2, which has replication into bucket 3, then any objects created in bucket 1 will be in bucket 2, but will not be replicated to bucket 3. So we cannot chain your replication. So that's a fine print for S3 replication. Now let's go to hands-on to see how that works. Okay, so let's have a play with S3 replication. Here is my S3 console. So I'm going to create a first bucket. So I'll say demo easy AWS origin 2022 and in US East 1. And here I am going to enable bucket versioning, because for replication you need to enable bucket versioning on both the source and the target bucket. So we will create those buckets, and so this is my first bucket created, demo easy AWS origin 2022, and it was in US East 1. But I am also going to create a second bucket called demo easy AWS replica 2022, and this time I am going to choose something like in the or EU West 1, for example, to replicate my data from US into the EU. Maybe it is a disaster recovery strategy for yours. Okay, so I'll scroll down. I will enable bucket versioning again and simply click on create bucket. Okay, so now both my buckets have been created. So my origin buckets and my replica buckets, and now let's open them in new tabs. What I want to do is start uploading one object into my demo easy AWS origin 2022. So I will upload here the castle.jpg file and simply upload it. Here we go. And so right now, as we can see, it is in my demo origin bucket, but obviously we have not configured anything, so it is not yet in my demo replica bucket. Okay, so for this, now I want to set up replication. So you need to go into management, and here under the management there is replication rules. So we can create a replication rule here, and I will just call it as demo rule, and the rule is enabled. And what we do is we can limit this rule to a specific scope within the bucket, so a subset of objects, or we can specify that this rule applies to all objects in the buckets. So it is up to you, but right now we want to keep it simple, so let's apply it to all objects and the buckets. Next, we need to destination, so it could be bucket in this account or in another account. So let's choose a bucket in this account. Now we will browse S3 the demo replica bucket, so we'll choose this. And as we can see, the destination region is now EU West 1, and so this is cross region replication. But if the destination region was the same, it would be a same region replication. For your replication setting, okay, so finally you need an IAM role here to perform this action. And so we can just ask Amazon S3 to create this role for us, which is very nice. Now, in term of advanced setting, I'm just not going to check anything. We just want to demonstrate the capacity right now. So, and here the delete marker replication right now is disabled. So delete markers are not replicated, but if you enable it, delete markers would be replicated, and it will demonstrate this in a second. But right now I will leave this as delete marker replication off. Okay, so I will save this, and now my replication rule has been created and currently configured. So what you would expect is that if we go into the origin bucket, we see one object castle.jpg. And if we go into the replica bucket here and refresh it, well, we'll still see zero object here. So it turns out that as soon as you enable replication, it will not replicate old object for you, previous objects. So it will only replicate newer objects. So how do we fix this? Well, we can upload the castle JPEG file again. So let's upload castle.jpg and simply click on upload. Now this has uploaded the castle.jpg file here again in my bucket. So if I list version now of 2, and you can see we have a new version of this file. Now if I go to my replica bucket and here refresh it, within a few seconds I should be seeing this object popping up. And here we go, my object has now appeared, and we can look at the fact that the version ID of this castle.jpg is the exact same as the version ID I have on my origin bucket, as you can see. So the object is replicated including the object version ID. And if I upload, for example, here mountain.jpg, it's obvious that if it is also going to be replicated. So hopefully this makes sense. Now let's look about delete. So if I take my castle.jpg here and delete it, so I'm going to create a delete marker and press and click on delete. So this delete marker that is created is not going to be replicated. So let's prove it to our save. So right now we only have the mountain.jpg in here in the origin bucket, and if I refresh here, I have castle.jpg. So the delete marker did not get passed on to the our replica bucket, and we started from before. This was just a setting in the replication rule. So if we specify, we could also tell Amazon S3 to replicate this delete marker, but this is something you have to opt in by default. And finally, if I list my versions and say I wanted to delete a very specific version of my file, so let's say delete all these files right here, and I will permanently delete this because I am deleting specific version IDs in my buckets. So this is something good to know, and definitely a behavior you should be aware of at your exam. Okay, and that's it for replication rules. I would say you can set up different replication rule in your buckets based on different prefix and filters, and you can edit the rule if you wanted to. For example, if you wanted to delete the marker replication as well to enable it, but for now we will not do it. We show the basic of replication, and that should be enough for the exam. S3 storage classes, and into the exam you need to know about all storage classes and understand which one is most adapted to which use case, right? So this lecture is going to be quite long, and I want to describe to you all the different storage classes. So let's get start the session. The first one is the one we have been using so far, which is Amazon S3 standard, which is for general purpose, but there are some more optimized one depending on your workload. The first one is S3 infrequent access or IA, also called as S3 IA. So this one is when your file are gonna be infinitely accessed, and we will have a deep dive by the way on all of them, right? There is gonna be S3 one zone IA when we can recreate data. There is gonna be S3 intelligent tiering, which is going to move data between your storage classes intelligently, and now Amazon Glacier for archive, and Amazon Glacier Deep Archive. For the archiving, you don't need right away. Finally, there's one last class called Amazon S3 Reduced Redundancy Storage, which is deprecated, and therefore I will not be describing it in detail through this session. Okay, so S3 standard general purpose. We have very high durability is called 11 nines, so 99.9 times 9 of objects across multiple AZ. So if you store 10 million objects with Amazon S3 general purpose, you can on average expect to incur a loss of a single object one every 10,000 years. Bottom line is, you should not lose any objects on S3 standard. There is a 99.99 availability percentage over a given year. And all these numbers, by the way, you don't have to remember. This is just indicative to give you some knowledge. You don't need to remember exactly the number going into the exam, just since you understand the general idea about a storage classes. And it can sustain two concurrent facility failure. So it's really resilient to AZ disaster. The use cases for general purpose is going to be big data analytics, mobile and gaming application, content distribution. This is basically anything we have been using so far. Now we have S3 standard infrequent access or IA, and this is suitable for data as the name indicates, that is less frequently accessed but requires a rapid access when needed. So we get the same durability across multiple AZ, but we have 1/9 less availability, and it is lower cost compared to Amazon S3 standard. The idea is that if you access your object less, you will not need to pay as much. It can sustain two concurrent facility failure, and the use cases for this is going to be a data store for disaster recovery, backups, or any files that you expect to access way less frequently. Now we have S3 one zone IA or infrequent access, and this is the same as IA, but now the data is stored in a single availability zone. Before it was stored in multiple availability zone, which will be let us into make sure the data was still available in case an AZ went down. So we have the same durability within the single AZ, but if that AZ is somewhat destroyed, so imagine an explosion or something like this, then you would lose your data, and you have less availability, 99.5% availability, and you have still the low latency and high throughput performance you would expect from S3. It supports SSL for all the encryption, and is going to be lower cost compared to infrequent access by about 20%. So now the use case for one zone IA is going to be to store secondary backup copies of on-premise data, or storing any type of data we can recreate. So what type of data can we recreate? Well, for example, we can recreate thumbnails for an image. So we can store the image on S3 general purpose, and we can store the thumbnail on S3 one zone infrequent access. And if we need to recreate that thumbnail over time, we can easily do that from the main image. Then we have S3 intelligent tiering, and it has the same low latency and high throughput as S3 standard, but there is a small monthly monitoring fees and auto tiering fees. And what this will do is that it will automatically move objects between the access tier based on the access patterns. So it will move objects between S3 general purpose, S3 IA, and so it will choose for you if your object is less frequently accessed or not. And here you are going to pay a fee for S3 to do that little monitoring. So the durability is the same, and it is designed for 99.9 availability, and it can resist an entire event that impact an availability zone. So it's available. Okay, so that's for general purpose S3 storage tiers. And then we have Amazon Glacier. So Glacier is going to be more around archive Glacier's cold. So think cold archive. It's a low cost object storage, meant really for archiving and backups. And the data needs to be retained for very long time. So we are talking about tens of years to retain the data in Glacier. It's a big alternative to on-premise magnetic type storage where you would store data on magnetic tapes and put these tapes away. And so if you wanted to retrieve the data from these tapes, you would have to find the tape manually, put it somewhere, and then restore the data from it. So we have still the 11 lines of durability, so we don't lose object, and the cost per storage is really low, $0.004 per gigabyte plus a retrieval cost. And well, see that cost in a second. So each item in Glacier is not called an object, it's called an archive, and each archive can be a file up to 40 terabyte. And archives are stored not in bucket, they are stored in vaults. Okay, so we have two tiers within Amazon Glacier we need to know about. The first one is Amazon Glacier, the basic ones, and we have three retrieval option, and they are very important to understand. Expedited, which is 1 to 5 minutes, so you request your file and between 1 to 5 minutes you will get it back. Standard, which is 3 to 5 hours, so you wait a much longer time. And bulk, when you require multiple files retrieval at the same time, which takes between 5 to 12 hours to give you back your file. So as you can see here, Amazon Glacier is really to retrieve files and not have some kind of urgency around it. If you are very in a rush, you can go and use expedited, but it's going to be a lot more expensive than using standard or bulk. And the minimum storage duration for Glacier is going to be 19 days. So again, files that are going to be in Glacier are therefore the longer term, and we have an even deeper storage tier for Glacier called Deep Archive, and this is for super long term storage, and it's going to be even cheaper. But this time the retrieval option are standard 12 hours, so you cannot retrieve a file in less than 12 hours. And bulk, if you have multiple files and you can wait up to 48 hours, it's gonna be even cheaper. So deep archive, we will see, is going to be for files that you really don't need to retrieve urgently even if it's archived. And minimum storage duration of for deep archive is going to be 180 days. Now you have to remember these numbers at a high level because going into the exam there will be question asking you to understand which point to pick between Glacier and Glacier Deep Archive. And for example, if the storage file is going to be less than 180 days, then you have to use Glacier. If you need to retrieve the file very quickly between 3 to 5 hours, is going to be Glacier. But if it's going to be file to be retrieved in 72 hours and is going to stay for 1 year in your vault in Glacier, then maybe deep archive is going to be provide you the best cost saving. So let's compare everything that we have seen. So we have seen S3 standard, intelligent tiering, standard IA, one zone IA, glacier, and glacier deep archive. So for durability, there is all 11 nines. So that means you don't lose any object for availability. While the ones that we can look at is S3IA, because it's a infrequently accessed, we have a little bit less availability. And if it's one zone IA, then it's going to be even less availability because we only have one availabilities on them. So that makes sense. For the SLA, this is what Amazon would guarantee you to reimburse you, and it's not something you need to know about, but I will just put it in this chart in case you need it in real life. So now the number AZ your data is stored onto is going to be 3 everywhere except in one zone IA, because as the name indicates it's only for one zone. So you are going to have one, then there is a minimum capacity to charge per object. So when you have the normal S3 or intelligent tiering, you are fine. But when you are using IA, you need to have a large object large rather large than 128 kilobyte, and for glacier it's 40 kilobytes. The minimum storage duration is going to be 30 days for standard IA, 30 days for one zone IA, and for glacier is 90 days. For Glacier Deep Archive, it's 180 days. And then finally, is there a retrieve fees? For the first two, no, there is not, but it's when you have standard IA, because it's infrequently accessed, then you are going to be charged a fees anytime you retrieve the data. And then for Glacier Deep Archive, again, there is going to be a fees based on the number of gigabyte you received and the speed you want to receive it. So you don't need to know all the numbers in it, but the number should make sense from what the storage tier really means to you. Okay. And for those who like numbers, here just the chart that I have. You can look up on your own time, but what it shows is that the cost of SD standard is 0.023, which is high. And if we go all the way to the right to glacier, we have deep archive. So we have 0.00099 per gigabyte per month, which is a lot cheaper. And so if you want to if you want the data fast enough for intelligent tiering, is gonna be between 0.23 and 0.0125. Standard IA is going to be that number, and one zone IA is gonna be even cheaper, and so on. And it shows also the retrieval cost. So if we want to expedite retrieval from glacier, it's going to cost us $10 per thousand requests, whereas if we use standard or bulk, it's going to cost us lot less. Same for glacier deep archive. Okay. And finally, for S3 intelligent tiering, there is a cost to monitor object, because it's gonna be able to move them between S3 standard and S3 standard IA on demand. And so the cost is quite small, but it's 0.0025 per thousand objects monitored per month. Okay, so that's it now. Now let's go into hands-on to see how we can use these tiers. So as you can see, this is my S3 console. Now let's have a look at storage classes. So I'm going to create a bucket here. Let's say demo 2022 storage classes. And I will scroll all the way down and simply create bucket. So this is a whole new bucket here, and I am going to upload my first object in here. So I am going to upload an object named castle.jpg. Okay, so if we expand the properties option, we can have a look at the storage class option. So here we get access to all the storage classes we have learned. So we have standard, intelligent tiering, standard IA, one zone IA, and so on. So we have all the option here, and there is a summary of what each storage class means. For example, how many AZ are available, the minimum storage duration, the minimum billable object size, some fees in terms of auto tiering, and retrieval fees. You can also click on this learn more and Amazon S3 pricing button and links if you want to if you want you to learn more and get access to the documentation, obviously, as well as the pricing documentation in case you have any doubt. So but for example, let's choose to upload this file in standard IA, which is infrequently accessed, and let's see if that works. So we will click on upload, and here we go. Our file has been uploaded, so I can happily upload another file now. For example, I can upload my mountain.jpg, and if I choose to upload my mountain.jpg in the glacier, then it will not allow me to see this file immediately unless I retrieve it. So let's have a look. So I have got to restore it first. So I have my mountain.jpg, and as you can see, the storage class is glacier. So whereas castle jpeg, the storage class is standard IA. So if I click on mountain.jpg, it says this object is stored in the glacier storage class. In order to access it, you must first restore it. So that makes sense. Whereas if I go to the castle.jpg, I am easily able to open and view it. For this mountain.jpg, I cannot open it. I first need to initiate a restore, which is going to take some days to restore. It could take between 5 to 12 hours if I do it with bulk retrieval. Standard is between 3 and 5 hours, and expedite between 1 and 5 minutes. And it's going to be a lot more expensive, right? And how many days do I want to want the restored copy to be available in days? So it's going to take a lot of time for me to show you this, but you get the idea because it is in glacier, then it's going to take some time to restore it, right? And finally, it is possible to you to edit the storage class of an object. So this object right here is in standard IA, as you can see, but I can edit it, and I can change the storage class to standard or one zone IA, or we just run on intelligent steering. So for example, let's move this to intelligent tiering. Save changes, and here we go. The storage class of that object has been changed. Lifecycle rules of Amazon S3. So let's get started the session. So you can transition objects between storage classes as we have seen in the previous hands-on on storage classes, right? So if you have not seen that video yet, please go and watch that first. So we can transition object, but we can do it in what way? Well, there is a giant graph on the AWS website that describes how to do it. So it's pretty complicated, but as you can see from standard IA, you can go to intelligent tiering, one zone IA, and then glacier, then deep archive. And it just shows the possible transition. And as you can see from glacier, you cannot go back to standard IA. You have to restore the objects and then copy that restored copy into IA if you wanted it to. So for infrequently accessed object, move them to standard IA. For archive objects that we do not need in real life, the general rules is to move them to glacier or deep archive. And so moving all these objects around all these classes can be done manually, but it can also be done automatically using something called a lifecycle configuration. And configuring those is something you are expected to know going into the exam. So lifecycle rules, what are they? You can define transition actions which are helpful when you want to transition your objects from one storage class to another. For example, you are saying move objects to standard IA class 16 days after creation and then move to Glacier for archiving 6 months later. So fairly easy and fairly natural. Expiration actions, which is to delete an object after some times. So for example, you access log files, maybe you don't need them after another year. So after a year, you will say, hey, all my files are over a year old. Please delete them. Please expire them. And it could also be used to delete old versions of a file. So if you have versioning enabled and you keep on overriding a file, and you will not need the previous version after maybe 60 days, then you can configure an expiration action to expire object old version of a file after 60 days. It can also be used to clean up and complete multi-part uploads in case some parts are hanging around for 30 years and they will never be completed. Then you would set up an expire action to remove these parts. And rules can be applied for a specific prefix. So if you have all your mp3 files within the mp3 prefix, then you can set a lifecycle rule just for that specific prefix. So you can have many lifecycle rules based on many prefix on your buckets. That makes sense, right? And you can also have rules created for a certain object tags. So if you want to have a rule that applies just to the object data tag like department, finance, then you can do so. So the exam will ask you some scenario questions, and here is one, and you need to think about it with me. So your application EC2 creates image thumbnails after profile photos are uploaded to Amazon S3, and these thumbnails can be easily recreated and will only need to be kept for 45 days. The source images should be able to be immediately retrieved for these 45 days, and afterward the user can wait up to 6 hours. How would you design this solution? So I will let you think for a second. Please pause the video and then we'll get to the solution. So the S3 source image can be on the standard class, and you can set up a lifecycle configuration to transition them to Glacier after 45 days. Why? Because they need to be archived afterward, and we can wait up to like 6 hours to retrieve them. And then for the thumbnails, they can be one zone IA. Why? Because we can recreate them, okay? And we can also set up a life cycle configuration to expire them or delete them after 45 days. So that makes sense, right? We don't need the thumbnail after 45 days, so let's delete them, and let's move the source image to Glacier, and the thumbnail can be on one zone IA because it's going to be cheaper, and in case we lose an entire AZ in AWS, we can easily from the source image recreate all the thumbnails. So this is going to be providing you the most cost efficient rules for your S3 buckets. Now, in second scenario, there is a role in your company that states that you should be able to recover your deleted S3 objects immediately for 15 days. Although this happens rarely, after this time and up to 1 year, deleted objects should be recoverable within 48 hours. So, how would you design this to make it cost efficient? Okay, let's do it now. So you need to enable S3 versioning, right? Because we want to delete these files, but we want to be able to recover them. And so with S3 versioning, we are going to have object versions, and the delete objects are going to be hidden by delete marker, and they can be easily recovered. But we are going to have a known current versions, basically the objects version from before, and So this non-current versions, we want to transition them into S3IA because it's very unlikely that these old objects versions are going to be accessed. But if it do are accessed, then you need to make sure to recover them immediately. And then after this 15 days of like glacier period to recover these non-current versions, you can transition them into deep archive, such as for 365 days it can be archived and then will be recoverable within 48 hours. Why don't we use just glacier? Well, because glacier will cost us little bit more money because we have a timeline of 48 hours, and so we can use all the tiers all the way up to deep archive to reach your file and get even more saving, right? So this is the kind of exam question you would get, and it's really important for you to understand exactly what the question is asking and what storage class is corresponding the best to it, and what lifecycle rules can also correspond to base to it. So now let's go into the hands-on just to set up lifecycle rules. Okay, so now let's have a look at lifecycle rules. So this is my bucket that we created in the last session, and now for this I'm gonna go into management and I can define here lifecycle rule. So let me create one. I will call this one, let's say, demo rule, and we can either play it to a specific scope within our bucket or all the objects. So I will apply to all the objects just for simplicity's sake in this video. So we have 5 different kind of lifecycle rule action. We can transition current version of object between storage classes or previous classes. So what do we mean by current and previous? Well, for current we mean the object that is the most recent if we have enabled versioning, and for previous we mean all the other version of an object if we have enabled versioning. Then we can expire current version of objects, permanently delete previous version of objects, and finally delete expired, delete markers or incomplete multi-part uploads. So lots of different option here, but let's just do this one. So we are going to transition current version of objects between storage classes, and we can say we can transition object into the standard IA storage class after, let's say, 30 days. Then we can move it to intelligent tiering after 70 days, and then move it into maybe glacier after 180 days, and then glacier deep archive after, let's say, 365 days. Okay, and here is a small warning. If you transition your small objects into glacier or glacier deep archive, this will increase cost. So obviously if you do transition objects there, make sure they are big enough. Okay, great. So next I can also expire current versions of objects. Now here, after an object is created, maybe after 700 days, then please delete it. And here we could also add a previous version transition just for fun, and we can say it's move it into glacier after, let's say, 60 days, because if it's approved version, maybe we don't want to access it, we don't plan on accessing that. Okay, so I acknowledge this, and so we can look at the timeline summary. And so for current version action, day 0 the objects are uploaded, day 30 they are transitioned automatically into standard IA, day 70 into intelligent tiering, day 180 to glacier, and finally 365 glacier deep archiving. Day 700 they will expire, and then for previous version action this year they become non-current, and day 60 they are transitioned to glacier. Just a simple fun life cycle rule to set up, but this shows you the whole power of life cycle rules, right? You can set up multiple ones per bucket on different filters with different rules, and this allow you to really optimize your cost in AWS for Amazon S3. Amazon S3 event notification. So without any further ado, let's get started the session. Okay, Amazon S3 event notifications. So some events happen in your S3 bucket. For example, this could be a new object created, an object removed, an object that has been restored, or there is some S3 replication happening, and so you want me to able to react to all these events. You can create rules, and for these rules you can also filter by object names. For example, you want to react only to the JPEG file, so start.jpg, and so you can create event notification rules, and these rules allow you to trigger some sort of innovation inside of your AWS account. So use case for it, a very classic one, will be to generate thumbnails of images uploaded to Amazon S3. So what are the possible targets for S3 event notifications? Well, so you have three. You have SNS, which is a simple notification service to send notifications and emails. We have SQS for a simple queue service to add messages into a queue. And finally, Lambda function to generate some custom code. Now, we will see all these service SNS, SQS and Lambda in detail in this series, but for now just remember that you have these three targets for Amazon S3 for event notification, and that will make a lot of sense by the end of this course. You can create as many S3 events as desired, and most of the time they will be delivered in seconds, but sometimes it can take a minute or longer. And there is a small caveat, which is that if you want you to make sure every single event notification is delivered, you need to enable versioning on your bucket. So this is what these two very long lines of text are saying, and this comes from the documentation. So let's go ahead in the console to see how we can set up a very simple S3 event notification. Okay, so this is my AWS S3 console, as you can see. Now let's demonstrate S3 bucket notifications. For this, I'm going to create a new bucket, and then I'll call it as demo 2022 S3 bucket notifications. Okay, I'll create it in US East 1 Virginia, and scroll all the way down and simply create this buckets. So next I will click and open this bucket, and I want to go into properties, and I want to change my event notifications. So as you can see, where we have multiple ones, so I want to create an event notification, and I will call it as demo event, and for the prefix it's optional, so I will set none. This way applies to all the objects within my buckets, as well as suffix is optional, and so on. Now what is this event happening applies to? So I want to have this event triggered anytime an object is created. So that is object created, put, post, copy and multi-part upload completed. But you could also, if you want to have other calendar events such as deletes event, restore events and so on. So for now I'm just going to select all objects create event for S3 object create to start. Next we need to choose a destination. And so the destination could be a Lambda function, an SNS topic, or SQS queue. Now we have not seen those yet, but we will be using an SQS queue and we will be creating a queue ourselves. So let's go ahead and create a queue. So let's go to SQS and create a queue for that matter. So we will create a queue, and this queue I'm going to call it as standard, and let's say demo S3 notifications. We are good to go, and I'll scroll all the way down and click on create queue. So my queue is now created, and what I need to do is to set up an access policy. And the access policy I need to set up is an access policy that will allow my S3 bucket to write to my Amazon SQS queue. So no need to worry about what SQS is right now, but just follow with me. So let me refresh this page just to make sure that I get my queue picked up. So we have to say demo event again one more time for create objects and scroll down SQS queue and find my demo S3 notifications. So now if I save the changes right now, is going to give me an error because I am unable to write to my SQS queue. So let's change the access policy to allow people to write to my SQS queue. So I will change it, and the access policy itself, I can use a policy generator to define an SQS queue policy. So and I will make it very permissive right now. So I'll allow anyone to do a send message into my SQS queue, and I need to find the ARN of my SQS queue, and the ARN is, you can see right here. So here we go. I'll paste it in the ARN, and a statement generate this policy, and this should allow anyone including my S3 buckets to write to my SQS queue. Now this is way too permissive but good enough for this demo. So I paste it and then I will save this. So now my access policy should allow my S3 buckets to write your SQS. So let's save the change one more time, and this time the operation successfully completes. Finally, let's go and upload an object to see if that triggers an event. So we will add a file and we will add castle.jpg and upload this file and see what happens. Okay, so this file has been successfully uploaded. This is good. Now let's go into my Amazon SQS, and under the Amazon SQS you can go to send and receive messages on the top right corner, and under receive messages this is going to receive this message. So here they are. So the first message is that, and if we look at the body, we can see that this was a test event from Amazon S3. This is when Amazon S3 was testing the connectivity between S3 bucket and the SQS queue. So we can safely disregard these events. And the second event, if you look at the body, now this contains the actual notification that was sent by Amazon S3 into SQS queue. So we can see the source is AWS S3. It was in the US East 1 region, and the event name was object create puts. We can see who did it and some IP here, and a lot of information about that event in particular. So this demonstrates that yes, our S3 bucket is able to send notification into Amazon SQS, and the completed demo. Now in this session we are going to discuss about AWS CloudFront. AWS CloudFront. AWS CrownFront is a content delivery network or CDN, and what it does is it improves read performance because the content is going to be distributed and cached at the edge location, and the edge location are all around the world, and there is about 216 points of preserved globally. As I'm recording this lecture, and they are all the time new point of presence, so it's much more than the 30 sometimes region that always is. This is a worldwide thing, and so what this platform gives you on top of this caching at the edge, well, it gives you DDoS protection. So to protect against attacks that are distributed denial of services. It gives you interaction with a shield and also a web application firewall. We will see those into the security session of the series. But the idea is that it's really protected and it's a good way to front your applications when you deploy them globally, and also allow you to expose an external HTTPS endpoint by loading the certificates, and also talk internally in HTTPS to your application if you need to encrypt that traffic as well. So let's take a diagram. So this is a map of the world, and there are some orange reason that everything on this graph is edge, but as you can see it's all around the globe. And so for example, say we have an S3 bucket in Australia and some users from America wants to access it. It's actually going to access an edge location close to it, so in America, and that network is going to be transmitted over the private AWS network all the way to the S3 bucket, and the content is going to be cached. So the idea is that this American user, with the more users you have in America, the more they will want to do the same kind of reads, and they will all have content served directly from America, not necessarily from Australia, because it will be fetched once into America and then served from there, so cached locally. So another user, maybe in Asia, will talk to a edge location closer to Asia, and that edge location again will support traffic to the S3 buckets to get the content and then cache it at the edge. So CloudFront allows you really to distribute your reads all around the world based on these different edge locations, and we improve latency and reduce the load on your main S3 bucket. Now, let's see what are the different CloudFront origins. Well, the first one is an S3 bucket, and you would use CloudFront in front of S3 as a very common pattern to distribute your files globally and cache them at the edge. You also get enhanced security as well. See in the hands-on between CloudFront and your S3 buckets using your CloudFront OAI or Origin Access Identity. And this allows you S3 bucket to only allow communication from CloudFront and from nowhere else, right? And then finally, you could also use CloudFront as an ingress to upload files into S3 from anywhere in the world. The other option is to use custom origin, and there must be an HTTP endpoints. So this could be anything that represent the HTTP protocol. So it could be an application load balancer. It could be an EC2 instance. It can be an S3 website. But we first must enable the bucket as a static S3 website, and note that it is different from an S3 buckets. And this debug website, we need to enable that setting as we have seen before, right? And we could be any HTTP backend you want. For example, if it was on your own premises infrastructure, okay? Now, how this platform work at a high level? So we have a bunch of edge location all around the globe, and they are connected to the origin we defined. it could be an S3 bucket, or it could be an HTTP endpoints, and our client wants to access our CloudFront distribution. For doing this, the client will send an HTTP request directly into CloudFront, and this is what an HTTP request would look like. There will be URL, some query, string, parameters, and there will be also some headers. And then the edge location will forward the request to your origin, and that includes the query strings and that includes the headers. So everything gets forwarded on to your origin, and then your origin responds to the edge location. The edge location will be cached the response based on the cache setting we have defined and return the response back to our clients. And the next time another client makes a similar request, the edge location will first look into the cache before forwarding the request to the origin. So that is the whole purpose of having a CDN. Okay, so very simple. This is how CloudFront works at the high level. Now let's look at S3 as an origin in detail. So you have the cloud and you have your origin, which is your S3 buckets. And for example, you have an edge location in Los Angeles, and for example you have and some users want to read some data from there. So your edge location is going to fetch the data from your S3 bucket over the private AWS network and give you the result from the edge location. The idea is that for the edge location of CloudFront to access your S3 buckets is going to use an OAI, or an origin access identity, is IAM role for your CloudFront origin. And using that role is going to access your S3 buckets. And the bucket policy is going to say yes, this role is accessible, and yes, send the file to CloudFront. So this works as well for other edge location. For example, in Sao Paulo in Brazil, or Mumbai, or Melbourne, or all around the world. Your edge location are going to serve cached content from your S3 buckets, and so we can see how CloudFront can become super helpful as a CDN. Now, what if have a ALB or EC2 as an origin? The security changed a little bit, so we have our EC2 instance or instances, and they must be public because they must be publicly accessible from HTTP standpoint. And we have our users all around the world, so they will access our edge location, and our edge location will access our EC2 instance. And as you can see, it traverses the security group. So the security group must allow the IPs of CloudFront edge location into the EC2 instances. And for this, there is a list of public IP for edge location that you can get on this website. And the idea is that the security group must allow all this public IP of edge location to allow CloudFront to fetch content from your EC2 instance. So that makes sense. Now, what if we use an ALB as an origin? So now we have a security group for the ALB, and the ALB must be public to be accessible by CloudFront. But the backend EC2 instances now can be private. So in terms of security groups for the EC2 instance, EC2 allow the security group of the load balancer. We have seen this extensively, and for the edge location, which are again public locations. It needs to access your ALB through the public network, and so that means that your security group for your ALB must allow the public IP of the edge location, the same public IP as we had from before. So two different architecture, same concept, but we better understand network security for S3, for ALB or EC2 in front or behind, I must say CloudFront. Now, CloudFront is a CDN, and it also has some really nice feature. So one of them is geo restriction. So you can restrict who can access your distribution. So you can provide a whitelist. We are saying, okay, users from this list of approved countries, and only this list can go to a CloudFront. Or we can say blacklist, where we are saying, okay, the user from these countries are not allowed to access our distribution, and the way the country is determined is using a third-party geo IP database, where the incoming IP is matched against it to figure out the country. So the use case for geo restriction will be when you have copyright laws to prevent access to your content, and you want to prove to regulator that you are indeed restricting content access from, say, France, if you have content in America. So hope that makes sense, hope that's very clear. All right, so that's it for this theory part, and now let's go into the AWS management console and do hands-on. Okay, so as you can see, this is my AWS management console. So let's go ahead and practice using CloudFront. But first, we need to create an S3 bucket. So here, I want you to create a bucket called demo CloudFront 2022 and V2 and a region. So I think this is good. I will leave all public access blocking, and simply I will scroll down, then just click on create my bucket. So this is the bucket that is going to host our website, and so click on view detail to go into the bucket, and here I am going to upload now 3 files into my bucket. So I will upload my index.html, my mountain.jpg, and the ksl.jpg. Upload. So all these files are uploaded, and what I want you to see is that these files, so if we take for example this index.html, we have two ways to access it. We can either access it using the object URL, but this is not going to work because my bucket is not public, so I am going to get an access denied, as you can see. Or we can say, for example, click on this open button, which actually generate a pre-signed URL, and this particular URL allows me to access my index.html file. But obviously my castle.jpg is not working for here. So as we can see, we have some way of accessing our files in S3, but we want to allow the access of these files to CloudFront. And so to do so, what I am going to do is just go into the CloudFront service itself. So I will look for the service named CloudFront, and we can observe that CloudFront is global service that does not require region selection, because we are deploying a CloudFront distribution all around the world. So we are going to create our first distribution here, and we need to choose an origin domain. So here we have different options. So we have Amazon S3, Elastic Load Balancer, etc, etc. As you can see, we have to choose Amazon S3. So we are going to choose this demo CloudFront bucket. But as you can see, you could enter here your own origin domain name if you wanted to. If you wanted to have a custom STB origin, right? But in this example, we are going to use Amazon S3. So I just use a drop down and select Amazon S3 bucket. Now the name of my origin is going to be like this. And we are going to create a OAI. So it's an origin access identity. And this is going to available because we are using S3 bucket, right? So here we have to create an OAI. So what I'm going to do is I am going to click on create OAI. This is going to create this OAI name right here. So I will click on create, and here I am able to choose this newly created OAI. So what is going to happen is that CloudFront is going to access my S3 bucket using this identity. And we can edit the bucket policy of the S3 bucket to allow real access to the OAI. So let's say yes. Let's update the bucket policy. And what we can do is we can check that if we go right now into permission, scroll down and look at the bucket policy. Well, currently the bucket policy is empty. Okay, so here we are going to scroll down, and then we are not going to change any of this setting for now. So let's scroll down all the way down, and the default root object is the file name that you wanted to return to your request if we are using the root URL. So we are just going to here index.html, and now let's click on create distribution, and the distribution is now deploying. It takes about 4 to 5 minutes, so let me pause the video. So my distribution is now created, and I can copy the distribution domain name, enter in a new tab, and simply press enter. And as you can see, we get hello world and then our castle.jpg file and so on. So that means that the CloudFront distribution is working. I can still not access my file directly by using the URL in Amazon S3. The only way I can access my file is by using this CloudFront. Okay, so CloudFront is distributing my content from Amazon S3. So here we can also do mountain.jpg for example, and yes, we can see the mountain.jpg file or obviously castle.jpg file. But the cool thing about is that now this file are cached. So that means that if I go back to my mountain.jpg file, it's actually not being served from Amazon S3 anymore. It's served directly from a CloudFront edge location. Same if I went back to my index.html, now the request does not make it go all the way through to Amazon S3. It is cached yet again in an edge location. So this really shows the power of using a CloudFront distribution on top of Amazon S3, because now this content is going to be available globally with low latency. The last thing I want to check is that if we go back to our permission here, as you can see, the bucket policy was empty. But if I refresh the page, now as you can see, the bucket policy is now not empty and it contains a statement that allows the principal, and this is CloudFront origin access identity principal to do get object and any resources in my S3 bucket. And we can have a look at the identity. So here on the left hand side, if I go and scroll down and look at origin access identities, we can find here the origin access identity that we have created, that is associated with our CloudFront distribution, and that is allowing us CloudFront mostly to get the content from the S3 buckets and then distribute it as a public URL.
So now in this session, we are going to discuss about some advanced options for CloudFront that can come up in the exam. So without any further ado, let's get start the session. So, first let's talk about multiple origins in the CloudFront, and then origin groups. So for example, you may want to redirect and route to different kinds of origins, based on the content type of the path being passed to CloudFront. For example, you have a path for images, a path for the API and a path for everything else. In which case in CloudFront you can set different cache behaviors with a path being determined in. For example, if you have this /API/* path, you can say that you need to have a response from the origin, being your application load balancer. But, in case anything else is requested, maybe everything else is steady content, then you should get that content out of your S3 buckets. And so, as we can see, we have defined the multiple origins, based on the path being in Amazon CloudFront, right? Now here, we can also set up origin groups, and this is a different use case. This is to increase high availability and do failover in case one origin has failed. So an origin group consists of one primary and one secondary origin. And if the primary origin fails, then CloudFront will try to failover to the second origin. So let's take an example. Say we have CloudFront, and we have an origin group made of two EC2 instances. The first one is going to be our primary origin, and the second one is going to be our secondary origin. So Amazon CloudFront will send a request to the first EC2 instance. And in case there is an error coming back from the EC2 instance, then Amazon platform will retry the same request on the origin B, and hopefully, this one will respond with an OK status code. So there is a failover happening. You can also use this with Amazon S3. So in this example, if we use S3 and CloudFront with origin groups, we can get to region-level high availability and disaster recovery. So let's have a look. We have an origin group made of two S3 buckets. The first one is going to be a primary origin, and the second one's going to be our secondary origin. And if these S3 buckets are in different regions, then we can set up replication between these buckets. So all the content of origin A will be replicated into origin B, right? Now if Amazon CloudFront sends a request, and we get an error from the first S3 bucket, because maybe there is a region-level outage, then CloudFront will try the same request onto another S3 buckets in another region that will have all the data as the first one because of the replication. And therefore this one should hopefully reply with an OK status. So it just gives you a great service and architecture to get regional level disaster recovery for Amazon, okay? Now, let's talk about pricing and price classes. So we know that CloudFront edge locations are all around the world, but because they're all around the world, the cost of data out per edge location will vary. And so, here is a table. So as you can see, based on the continent or geographic region that the edge location is in, then you will have a different pricing. So if you look at this table, if you look at Mexico, United States and Canada, the first 10 terabytes is going to cost $0.085 per gigabytes. But if you have the same edge location in India, is going to be about twice the cost at $0.170 per gigabyte of data transferred, and so on. And the more data is transferred out of CloudFront, the lower the cost. So if you transfer over 5 petabytes of data out of CloudFront, you're only going to pay $0.02 out of the United States, okay? So, the idea is that, from the left side to the right-hand side, you have a higher cost, which brings us to the price classes. So you have a choice you can make, and you can reduce the number of edge locations around the world that is going to be used for your CloudFront distribution in order to do cost reduction. And there are 3 price classes available. There is the price class All, which is giving you all regions, and obviously the best performance, but it's going to cost you a little bit more money, because as you can see, for example, an edge location in India will cost more than an edge location in the United States. You can do the price class 200, which gives you most regions but excludes the most expensive regions, and the price class 100, to only get the least expensive regions. And this is summarized in this table, right? Now finally, let's talk about field-level encryption. So this is to protect sensitive information through the application stack. And this adds an additional level of security alongside using encryption at the edge close to user. So the idea is that anytime a sensitive information is sent by the user, the edge location is going to encrypt it, and they will only be able to be decrypted if someone has access to a private key. And therefore, this will be using asymmetric encryption. So how does it work? Well, in the post requests being made to Amazon CloudFront, then they will be a set of fields that we want to be encrypted, up to 10 fields, and they will specify the public key to encrypt them with. So now, let's go through an example. We have a client taking over HTTPS to edge location, which will be forwarding it to the CloudFront service using HTTPs again. And then, it will go all the way to the origin using HTTPS through application load balancer, which will forward all the data using HTTPS to your web server. So everything is encrypted in flights, but we want to specify field-level encryption. So say for example, that our user is sending us some credit card information. We specify that we want to have it field-level encryption for the credit card information. And therefore the edge location will encrypt that field using a public key. So now, the data being passed from the edge location to Amazon CloudFront to the origin will have the credit card information being encrypted by the public key. And so, the information will be passed all along until the web server. And then the web server will have access to the private key, and we'll be able to decrypt that encrypted field using the private key to decrypt and get the credit card number. As we can see, all along the stack, none of the CloudFront location and application load balancer will have the opportunity to decrease that field. Only the web server will need to have some custom application logic to decrypt that field, okay? Now in this session we are going to talk about Amazon FSx. So without any further ado, let's get started the session. FSx is a managed service on AWS, which allows you to launch third-party high-performance file system in AWS. And it is fully managed service, and the idea is that maybe sometimes you don't want to use Amazon S3, you don't want to use EFS, you want to use something else, and you may want to use, for example, Lustre, or Window File Server, or NetApp ONTAP. So from an exam perspective, you should think of FSx as a way to launch third-party high-performance file systems. And the exam will test you on FSx for Lustre, and FSx for Windows File Server. For NetApp ONTAP it does not cover the exam. So in this session, I will only cover FSx for Lustre, and FSx of Windows File Server. So first let's talk about Amazon FSx for Windows and the problem statements. So let's explore first Amazon FSx for Windows File Server. So EFS was to give a shared POSIX system for Linux system. And FSx for Windows is similar, is going to give you a fully managed Windows file system shared drive, accessible for your Windows computers and also Linux computers. It supports the SMB protocol, as well as Windows NTFS, and it has Microsoft Active Directory integration, ACLs, and user quotas. So it gives you a file system that is shared for all your Windows machines easily. But you can also mount it on Linux EC2 instance, so it works both for Windows and Linux, but remember this is a Windows file system. Now it can scale up to tens of gigabytes per second, millions of IOPS, and hundreds of petabytes of data. Now storage options for your FSx for Windows are either to use an SSD, and this is when you want to have latency sensitive workloads, or HDD. This is a hard drive for another kind of workload such as a home directory or a CMS and so on, but latency is less important. So SSD is of course going to be more expensive than HDD. Now FSx for Windows can be also accessed from your on-premises infrastructure using a VPN or the Direct Connect service. You can configure it to be multi-as, and provide you high availability. You can also back up your data daily to Amazon S3. Now let's talk about the second kind of Amazon FSx, which is Amazon FSx for Lustre. So Lustre is used to do a distributed file system that is going to be used for large-scale computing. So Lustre is the derived from Linux and cluster. It is used for machine learning and high-performance computing, or HPC, and this is a keyword you need to look for to know that you need FSx for Lustre. So you can have applications such as video processing, financial modeling, electronic design automation. You have massive scale, so you can scale up to hundreds of gigabytes of data per second, millions of IOPS, and sub-milliseconds latency. For storage, we have two options. Either you want an SSD for very low latency, IOPS intensive workload as well as small and random file operations, or HDD. If you want throughput intensive workloads for large and sequential file operations. You have seamless integration with Amazon S3, that means that you can read S3 as a file system through FSx, and you can write the output of the computations from FSx back to Amazon S3. Finally, it can be used from on-premises servers, through VPN or Direct Connect. So now let's do a quick overview of Amazon FSx, and FSx is not something you're expected to know how to create, it is good for us to just see the options. So as you can see, we are in our FSx file system. So, let's create a file system. Here as you can see, we have 4 options. So, we have NetApp ONTAP, we have OpenZFS, we have Windows File Server, and Lustre. But the exam will really focus on the Windows File Server and the Lustre type of file systems for FSX. So first, let's consider just Windows File Server. So this is going to give us a managed Windows File Server file system. And then I click on Next. And we can see the different options we have. So we have multi-as and single-as. Definitely you want to use a multi-as for production, and single-as for testing. Storage type we have SSD, or HDD. And then, the size of your Windows file server, so between 32 GB and 64 TB. Then based on whatever you said, so for example I say 16,000 GB, based on what you say. Then the throughput capacity is going to be either the recommended one, or you can specify what throughput you want for your file system. Here in a VPC with different subnets, and so on. You integrate with Windows authentication, because this is a Windows file server. Here you can encrypt it. And then we can control the auditing. You can control the access, the backup and maintenance and so on. But again, we keep things at a high level just to show you the important things. That you can have a multi-as and a single-as, SSD and HDD and so on. Now next, if you go to Amazon FSX for Lustre. So this is for high-performance computing HPC and this is super important to know. So I click on Next. And we have this file system. So we have 2 options, we can get a persistence on SSD, or persistence HDD. Or we can get a scratch SDD. So persistent is good for longer-term storage and workloads, and the data is going to be replicated in case the servers fail. And the scratch file systems are ideal for temporary storage and short-term processing of data. So we can do persistence SSD for example. And we can define it throughputs. So do we want to have 125 megabytes per second, per terabyte of storage? And then how many terabytes do you want? So 1.2 terabytes sounds great, which gives us a throughput of 150 megabytes per second. Do we want compression on the data? And what version of Lustre do we want? Then we have the same settings from before. So network settings, encryption settings, imports and backup maintenance. So guys, this is it for FSX, I hope you like it. We are going to discuss Amazon Quick Site, a business intelligence tool provided by Amazon. In today's session, first we will see, what is Amazon Quick Site? And then we will see, what is Amazon Quick Site used for? So without any further ado let's get start the session. So first let's see what is Amazon Quick Site. Amazon Quick Site is a machine learning powered business intelligence service built for the cloud under the Amazon Web Services umbrella. It enables firms to make smarter data-driven decisions. It is very simple, cost-effective, and user-friendly cloud-based business intelligence tool that allows companies to create and analyze the different kinds of data visualization. Amazon Quick Site is scalable, so it can support thousands of users without additional infrastructure management or capacity planning. And it is also device agnostic. Now let's see, what is Amazon Quick Site used for? Amazon Quick Site enables companies to access and explore deeper insights in an interactive visual environment. It includes natural language query capability, so users can ask questions of their data in plain English. So what Amazon Quick Site does is, it uses different kinds of methods and programs to collect the data from different sources. And then runs query against data and creates reports. Moreover, it allows to create different kinds of dashboards and provides data visualization so that organization can make better decision. Now, when the data is presented the way the company wants it, it becomes easy for organization to make decision, which otherwise would be difficult. Now here is the major benefits of Amazon Quick Site. First, it is easy to set up and use. Quick Site requires no complex server setups, data models, or capacity planning, so users can get going quickly. Fast performance. SPICE, Quick Site's in-memory calculation engine, automatically replicates data for high availability while saving time, money and resources. Low total cost of ownership. With a pay-per-session model for dashboard readers or consumers, users won't incur any upfront costs for licenses. Compatible with multiple data sources. Quick Site is compatible with many sources, So users can get insights from SaaS applications, third-party databases, native AWS services, private Amazon virtual private cloud subnets, and more. Anytime, anywhere access to dashboards and visualizations. With QuickSight Mobile, users can get insights from their data on any device from any location. The mobile-optimized experience includes capabilities like drill downs, filters, forecasting, email alerts, and collaborative viewing and sharing. So guys, that was the theory part. Now we have arrived at fun part of the session. So let's go and create some data visualization using Amazon QuickSight. So guys, this is my AWS Management Console. So first here, let's search for Amazon QuickSight. Click on it. So since I have used QuickSight before, it'll directly take me to the QuickSight homepage. But if you're using QuickSight for first time, you'll have to link your QuickSight account with your AWS account. Once you've done that, once you've synced your AWS account with your QuickSight account, will be taken to this page. So here, as you can see, QuickSight provides you with a lot of sample data visualizations. So go ahead and have a look at them. You'll understand what else you can do using QuickSight. Well, if you're trying to create a data visualization of your own, then you can go ahead and click on New Analysis option here. And click on New Dataset. Here, as you can see, QuickSight provides you with an option where you can upload a file, or connect to databases like MySQL, SQL Server, or you can go ahead and inject data from storage services like RDS, Redshift, S3. And here on the right side, you can see the Spice engine. It provides you with 1 GB free space. Now for the purpose of this demo, I'm going to upload a file. So there is this website called data.gov, where you'll find datasets on vast amount of topics, like you have climate, then you have energy, ocean, and many of the topics. So go ahead and select dataset of your choice for this demo. I have already downloaded the dataset I want. So let's upload a file. Here is the file. Now the file has been successfully uploaded. You can always go ahead and click on the next option, which will take you directly to the data visualization page. But it's always better to prepare data. You can click on the Edit Setting and Prepare Data option here. So what is the logic behind prepare the data? So when you download the file, it is possible that there might be some columns which are unnecessary for you. For example, let's say time 2 column which I don't need. So in the left side, I am going to select this time 2, and simply click on Exclude Field. So now you can see that only 4 columns are displayed now. This way you can prepare your data. According to your need, you prepare your data here. Now when you click on Publish and Visualize here. Here on the right side you can see that it's saying, the data is being imported to this Spice engine. Now it says import is successfully completed. Here you can see the columns which I have selected are displayed. And here, you can see the different kinds of data visualization types you want. Here you have KPI, gauge chart, donut chart, pie chart, and many other chart. So here I am going to select the pie chart here. And here in the group section, I am going to select review. So it is going to display a pie chart based on the review. So here we can see, we have 3.36 good, high SNR. So this way you can create different types of data visualization of your choice. And you can further customize by using more formatting option as well. I hope you understood as how to use data visualization. Be sure to try different data combination of your type to understand QuickSight little better. So go ahead and download different dataset and try creating different visualization. You will able to understand QuickSight practically. In this session, we are going to discuss Amazon SageMaker. In today's session, first, we will see, what is SageMaker? Then I am going to show you how it works. So without any further ado, let's get start the session. So first of all, let's see, what SageMaker is. Amazon SageMaker is a managed service in the Amazon Web Services public cloud. It provides the tools to build, train and deploy machine learning models for predictive analytics applications. The platform automates the tedious work of building a production-ready artificial intelligence pipeline. Deploying machine learning models is challenging, even for experienced application developers. Amazon SageMaker aims to simplify the process. It uses common algorithms and other tools to accelerate the machine learning process. Now let's see, how does Amazon SageMaker work? So here, as you can see, I have logged in into my AWS Management Console. So, first, let's search for SageMaker. Click on it. Here is the home page of Amazon SageMaker. Here you will find that SageMaker covers the entire machine learning workflow. Starting from labeling the data, you can actually outsource labeling and basically labelers all over the world to label your data. The next one, once you do that, then you will able to actually create a notebook instance and you will be able to leverage a lot of readily made available notebook for you. And once you do that, then you will be able to train and tune the model at any scale. And once the model is trained, and everything is good, then you will able to take that model and just create an endpoint to make inferences. So you will be able to invoke that endpoint and anyone can literally go ahead and make predictions based on this endpoint. You can also you can buy any readily available model for you from AWS Marketplace, which is pretty amazing feature to have. So let's start with a couple of features here. Again, I will not be able to go through all of them. Again, there are tons of ins and outs in it. Let's start with this basic one, a labeling job. So here, you can go ahead and create a labeling job. Here you can simply give a name to the job. Here you can specify the source of your data in S3, and you can specify the location here. Then you can specify the IAM role, which is simply the level of access that you want to give to SageMaker. And then here you can specify the task category. Let's say I want to label image. I want to label text. Want to label video. Even we can use custom label also. And then you can go here, and you can specify what type of labeling job you want to perform. You can select image classification for single label. For multi-label, you can select bounding box to draw bounding box. You can even do semantic segmentation, in which you actually go there and perform pixel level segmentation of the scene, and that would be very useful for self-driving cars, for example. And you can also do label verification, simply to ask workers to verify existing labels in your data set as well. So after you said that, you can just say, next. And you can simply afterwards go ahead and leverage Mechanical Turk to do labeling course to kickstart a labeling job for you. Again, I'm not gonna be showing exactly all the details of how to create the labeling job. I just want to show you from a very high level what's happening within SageMaker. Now here we can go ahead to my notebook instances, and here I can simply create a notebook instance. Here let's click on Create Notebook Instance. Here you can specify a name. Let's say, SageMaker, Demo. And then you can go here, and select what type of instance you are looking for. Let's go with the basic. Here you can provide the permission and encryption. Here you need to specify the IAM role to your notebook instance. And then you can simply say, Create Notebook Instance. Here you will find the notebook instance is being created for you. Now it shows status as pending. So it'll take little bit of time to actually being available. But once it's available, then you will be able to go ahead and kickstart a Jupyter notebook in there. So you'll be able to write Python code, you'll be able to upload your data, you'll be able to do whatever you want. Everything again is leveraged in the cloud, which is pretty amazing. Now if we go here, within the training, you can check out your training job. You can go ahead and create a training job. Here you can specify the job name. You can give it any name. Here you can specify the IAM role. And then here, you would able to use and leverage Amazon SageMaker built-in algorithm. Here you can actually go here and select the algorithm. Let's say I wanted to select XGBoost algorithm. I wanted to select object detection algorithm. So all these algorithms are already created for you. You just need to use them and tune them accordingly. Now once you do that, you need to specify the network. Again, you don't worry about all these details. Here you just need to specify the training channel, like where you are going to store the data. And after the model is basically being trained, all the trained model artifacts will be placed in S3 as well. So that will be the output data configuration for you here. And here you can also do spot training, just to optimize on the money that you will be spending to train it. And then you can simply go ahead and say create training job that will take of it for you. So let's go back. Now what you could do as well as after the model is trained, you can go here and say I want to check out my endpoint configurations. So you can go here, say I want to create an endpoint. Click on Create Endpoint Configuration. So here you can simply specify the name. Specify the type of endpoint. And then you can simply create an endpoint configuration, and that's it. And afterward, as well, you can also do augmented AI, which is kind of a way of augmenting human reviewers to review the performance of the model. We are not going to covering augmented AI in this session, but again it is a pretty cool feature that offered by AWS. And there is also AWS Marketplace. So if you click on all products, you would be able to literally just use trained models that other people done for you. So here you can say, I want to leverage face and license plate anonymizer, what's like an algorithm already been trained to detection and blurring of faces and license plate. You can just say, view product. And that will take you here, and you would be able to simply check out the pricing information, like they will charge you per hour. And you'll be able to go ahead and even like have a free trial as well if you want to check out the model for 5 days for example. Alright, so let's go back to our notebook instances. So if you guys remember we started one, and now it shows in service. You can go ahead and click on Open Jupyter. And here we go, here I have my Jupyter notebook. So here I will be able to upload any job, upload the data as well to my instance. So here I can say click on upload, and I will be able to upload my instance. Another cool feature is, if you go here, you will find there are SageMaker examples, and you will find that there are a tons of example available for you, such as if you want to leverage for example Linear Learner, or XGBoost. Here you can simply click on preview. And here you will find here a ton of examples of codes for you available. And you know like all the different basically the stages, including training the model, including the hyperparameters optimization, and how to host the model and create endpoints as well. So guys, this is how AWS SageMaker at very high level works and what are the different elements or key features within it. So guys, that's it for this video. I hope you liked it. I will see you in the next lecture. If you have any question or any doubt, feel free to ask in the comment section below. I will answer you as soon as I can. Thank you for watching. Bye and have a nice day.